Earth Science, Chapter 6, Section 2, Energy from Coal. Digging deeper. Coal as a fossil fuel. Energy resources, such as fossil fuels, hydropower, nuclear power, and geothermal, come from four primary sources. Two of these are solar radiation and Earth's interior heat. The other sources come from the decay of radioactive material in Earth and the tides. You can assume that starlight, moonlight, and the kinetic energy of meteorites hitting Earth are so small that you can ignore them. The energy in coal is from solar radiation that is stored as chemical energy in rock. The energy in coal starts out as solar energy. Green plants convert solar energy into chemical energy. The name of this process is photosynthesis. This energy is stored in plants as chemical energy. Only 0.06%, so only 0.06% of the solar energy that reaches Earth is stored in plants. However, that amount of energy is huge. Photosynthesis uses solar energy to convert carbon dioxide into sugar and water. The sugar is glucose. Glucose is an organic molecule. This means that it is a carbon-based molecule. The reaction is shown in the equation below. The energy stored in glucose is released when bonds holding the molecule together are broken and then form new, stronger bonds. The reaction is called oxidation. Oxidation occurs through respiration. It also takes place in decomposition. Combustion also releases the stored energy. Coal and the carbon cycle. You can see from the reactants and the products that photosynthesis and oxidation are the reverse of each other. The energy that enters the biosphere by photosynthesis is nearly equal to the energy lost from the biosphere by oxidation. Most of the carbon in the biosphere is soon returned to the atmosphere as carbon dioxide. A very small percentage of it is buried in sediments. There it is protected from oxidation and becomes part of the lithosphere. It is found in the form of peat, coal, and petroleum. These are called fossil fuels. They can be used at a future time. The rate of storage of energy used by organisms is very slow. Yet, these processes have been active throughout much of Earth's history. Therefore, the amount of energy stored as fossil fuels is huge. However, fossil fuels are consumed far faster than they form. Therefore, they are classified as non-renewable resources. The formation of coal. Most coal starts out as peat. Peat is an unconsolidated and porous deposit of plant remains from a bog or swamp. Structures of the plant matter, such as stems, leaves, and bark, can be seen in peat. When dried, peat burns freely. In some parts of the world, it is used for fuel. Today, most peat comes from peat bogs that formed during the retreat of the last ice sheets. That was between 10,000 and 20,000 years ago, the end of the Ice Age. Coal, by definition, is a combustible rock. More than 50% of coal by weight is material made of carbon. Coal is formed by compaction and hardening of plant remains, similar to those in peat. The plant remains are altered physically and chemically. This takes place as a result of bacterial decay, compaction, and heat. Most coal was formed from the lush growth of plants in coastal freshwater swamps. These are called coal swamps. They are found in low-lying areas that are separated from any sources of mud and sand. Plants here are rooted down into earlier deposits of plant remains. When these plants die, they serve as the roots of even later plants. In such an environment, the accumulation of plant debris exceeds the rate of bacterial decay of the debris. The bacterial decay rate is reduced because the oxygen available in organic rich water is completely used up by the decay process. Thick deposits of almost pure plant remains build up in this way. Coal swamps are now rare, but they were widespread at various times in the geologic past. For plant material to become coal, it must be buried by sediment. The plant material is compacted by the great weight of overlying sediment. During compaction, much of the water that was in the pore spaces of the plant material is squeezed out. As the material undergoes change, gas is produced. Methane is one of those gases. The gas is forced out of the deposit. The percentage of the deposit that is made up of carbon becomes greater and greater. As the coal becomes enriched carbon, it is said to increase in rank. The stages in the rank of coal are as follows. And let me scroll up a little bit because this figure has to do with this section here, this segment here. The stages in the rank of coal are as follows: peat, lignite, bituminous coal, anthracite coal, and finally graphite, a pure carbon mineral. It is estimated that it takes 10 feet of original peat material to produce a thickness of 1 foot of bituminous coal. Figure 3, increasing time, pressure, and heat result in the formation of progressively higher ranking coal. Coal is always found between layers of other sedimentary rocks. These are mainly sandstones and shales. Environments of sediment deposition change with time. An area that at one time was a coal swamp might later have become buried by sand or mud from some nearby river system. Eventually, the coal swamp might have returned. Upon burial, the plant material is converted to coal. The sand and mud form sandstone and shale beds. In this way, coal beds alternate with other sedimentary rock types. Some coal beds are only centimeters thick. These beds are not economically important. Coal beds that are mined can be up to several meters thick. In Figure 4, coal layers and the sequences of rocks in which they are found provide clues about changes in past environments. Here we can see how coastal swamps were buried and preserved as sea level changed in the past. And here, as you can see, are the coal layers. Types of coal. The type of coal that is found in a given region depends in part on the original plant material. It also depends on small amounts of impurities that were deposited at the same time. Mainly, the type of coal depends on the depth and temperature of burial. Coal that is buried very deeply reaches high rank. This results from the high pressures and temperatures of deep burial. Low rank coals, lignite and subbituminous, have not been buried as deeply. Coal varies greatly in its makeup. One of the most important features of coal is sulfur content. Sulfur is important because it is released into the atmosphere as sulfur dioxide when the coal is burned. It then combines with water in the atmosphere to form sulfuric acid. This causes acid rain. The sulfur content of coal can range from just 1% to as much as 5%. The percentage depends mainly on the sulfur content of the original plant material. The carbon content of coal increases with increasing rank of coal. Lignite has the least amount of carbon, anthracite has the most, as seen in Table 3. The heat content is also an important feature of coal. The greater the heat content, the smaller the mass of coal that needs to be burned to produce the needed heat. The heat content of coal increases with the rank of the coal. It depends mainly on the carbon content. And here's the relationship between carbon content and heat content. As the carbon content increases, the heat content increases. And coals are ranked, the different types of coal are ranked from low carbon content to high carbon content, as well as low heat content, BTUs per pound, to high heat content. The carbon content of coal supplies most of its heat energy per unit weight. The amount of energy in coal is expressed in British thermal units, BTUs, per pound. 1 BTU is the amount of heat needed to raise the temperature of 1 pound of water 1 degree Fahrenheit. Peat can be used as a source of fuel. However, it has a very low heat content. Lignite, also called brown coal, is the least buried and usually the youngest type of coal. It is used mainly for electric power generation. Subbituminous coal is a desirable heat source because of its often low sulfur content. Subbituminous coal is found in the western United States and Alaska. Bituminous coal is the most abundant coal in the United States. There is a large deposit of it in the Appalachian Province in the east. Bituminous coal is used mainly for generating electricity. It is also used for making coke for the steel industry. Anthracite, found in a very small supply in the eastern United States, has been used mainly for home heating. Some parts of coal do not burn. The part of coal that does not burn is called ash. Most of the ash consists of sand, silt, and clay that were deposited in the coal swamp along with the plants. The purest coal has only a small fraction of 1% ash. The ash content of usable coal can be much higher. Some of the ash remains behind and some goes up the flue. Ash in coal is not desirable because it reduces the heat content slightly. It also must be removed and discarded. Coal exploration and mining. In 2015, 33% of electricity in the United States was produced from coal. There was a fall in coal production around the middle of the last century. This was in part due to the decline of the steel industry, which uses coal in steel production. In addition, oil and gas have largely replaced coal for transportation and home heating. However, beginning in the early 1960s and until approximately 2008, there was a steady increase in the production of coal. This was mainly because of the increasing demand for electricity. There was also the development of major coal fields in the western United States and Canada. Of all the fossil fuels, the largest reserves are in coal deposits, 92%. Three major factors determine which coals are economical for mining at this time. One is the cost it would take to transport the coal to where it would be used. Another is concern for the environment that comes with the mining and use of coal. Lastly, the quality, thickness, volume, and depth of coal are important in assessing whether or not the coal is mined. Over the last 15 years, the mix of fuel types used to generate electricity in the United States has changed. The use of coal has decreased and the use of natural gas has increased. Figure 6 shows that increases in the use of renewable energy sources and nuclear power also occurred, but were less. The decline in the use of coal reflects a lowering of natural gas prices over time. Between 2000 and 2008, coal was relatively less expensive than natural gas. It supplied nearly 50% of the United States' electricity generation. Since 2009, large quantities of natural gas have been produced from shale rocks. This has driven prices down and made coal less competitive. In 2015, there were 511 coal powered electric plants in the United States. They generated 34% of the nation's electricity that year. Regulations have also caused coal to be less popular. Power stations are required to reduce their emissions of carbon dioxide. To achieve lower levels of emissions, plants must change their technology or reduce the amount of coal they burn. Figure 7 shows underground and surface mining methods. Let me scroll back up to Figure 7. Figure 7 shows underground and surface mining methods. Note, you would not typically see all these mining methods used in one location. Underground mining methods include drift, slope, and shaft mining. Surface mining methods include area, contour, mountaintop removal, and auger mining. An auger is a tool used for boring a hole. Figure 8 shows a surface coal mine. A mine high wall showing layered sandstone and mudstone in a Gulf Coast coal mine. And look, you can see the layers of coal there, the dark layers. Okay.